Hi everyone, I'm Arvind Narayanan. I'm an assistant professor here. I'm going to talk about ethical training today, ethical training of software engineers, perhaps a little bit of an unusual topic. I'll say a little bit more about myself a few slides in, but let me give you the motivation for why I wanted to talk about this. Everywhere we look today, we see lots of examples of the kind of power that technologists have today, especially software engineers. Let's think about the latest NSA leak from about a week ago. This was the story about the NSA physically tapping into the links between different Google data centers and the links between Yahoo data centers, right? So this was one of the New York Times stories about this, focusing on the anger from tech companies and how they're promising to fix this. Now, we're at an interesting time in history in terms of governments getting very ambitious about surveillance, but probably not a unique time in history. What I would argue, though, is different this time. What is different this time is that there are technological fixes available, not panaceas, but fixes that can help a lot, specifically cryptography, that are available to any company or to any private citizen, in particular, any software developer, to code and to deploy. In fact, Edward Snowden, in one of his interviews, said that properly implemented crypto systems are one of the few things that we can still rely on, even in the light of all of these leaks. So that is one point I wanted to highlight. The solution, for example, to this particular problem is just deploy IPsec on the data centers. Google or Yahoo is in a position to do that. Certainly they have to think about latency and efficiency and other issues, but it's not magic. It's not new technology that needs to be developed. And this is technology that's, it just rests on a piece of mat that's available to all of us. So that was one of the things I wanted to highlight in terms of the power that software developers have. The flip side of this, though, is interesting. There's also been an argument that it was, after all, because of the ambitions of these tech companies in collecting people's personal data and putting it in this model where everything is centralized in these data centers, that this problem even manifested in these forums. So that's an interesting flip side to think about there. So one can raise the issue of, do these companies and do the engineers of these companies have a larger obligation to the general public to think about these questions, or should they just be thinking about their bottom line? Speaking of the bottom line, I want to point to this famous quote by Jeff Hammerbacher that says, "The best minds of our generation are working on how to better make people click ads." Right? You've probably seen this quote, which raises the question about given that technologists have so much power, should we have a societal conversation about how they're spending their time and what they're using that to build, or is everybody just going to be working on whatever makes them the most money and whatever is the most fun to hack on? Yeah. By the way, every news story about Hammerbacher is like a very prominent data engineer comes up with a new appellation for him, like data whiz or data god or something, so I kind of data sorcerer, if you like it. Anyway. So if we were to accept this premise that making people click on ads is probably not the most socially productive thing, one can ask, are there good examples of amazingly socially beneficial things that software engineers could be doing? And I just wanted to point to the fact that yes, there are such examples, and I will just highlight one. The self-driving car technology, I'm just using Google's quote here. I haven't checked this myself, but their claim is that there are 1 million lives per year lost around the world due to car accidents, and self-driving cars, being much less error-prone than human drivers, can potentially save most of those lives. Again, there is an interesting flip side. It reminds us, when we think about self-driving cars, that when you think about the questions of liability that arise when you have a robot behind the wheel, we haven't even really developed a framework to start thinking about these questions. So there is a lot of progress that needs to be made, though, before this can become a reality and hit the roads. So two contrasting things. One is incredible amount of power and responsibility, and the other is not much of a framework to really start thinking about these questions here. Sorry. No worries. Right, so I wanted to start with that setup, and given that setup, here's what I would like to talk to you about today. I want to discuss three things. One is, I want to claim that there is a serious issue with the lack of ethical training that students get in software engineering or in computer science curricula, and in fact, I'm calling it a crisis, and I'll tell you why. And I want to discuss exactly why it is that ethics is currently not taught in the classroom. It's not just a simple matter of incorporating an additional lesson into the curriculum. I want to talk about some serious practical barriers there. And the third point is something perhaps unusual. I want to go into a little bit about cultural aspects here, what students do after they graduate and go on to the industry. And I want to look at hacker culture in particular in Silicon Valley and argue, throw it up for discussion at least, why it may be that it exacerbates a lot of these ethical issues that we're seeing. And finally, that's the why part. The how part is that I do have a few ideas about what is the best way for computer science educators to teach ethics in the classroom. And if you're not a professor, if you're a student or a practitioner, there's no reason to be waiting for a professor to come along to lead this discussion. These are what I want to share with you are things that anybody could start learning about and implementing right away. You might wonder, though, why am I the one talking about this? I'm not an ethicist. I'm a computer scientist. But at the same time, I would say that somebody has to talk about this. This is an overdue conversation. And if it were an ethicist with, who is not a computer scientist, that would not be the ideal person to talk about it either, because a lot of what I want to say draws upon my perspective as a computer science educator. In addition, I'm a computer science educator, but also a privacy and security researcher, and I feel that that's relevant to what I'm going to tell you today, because many of the ethical issues, not all of them, maybe not even the majority, but many, are about privacy and security. And finally, I spent several years in Silicon Valley, for example, interviewed with Y Combinator, been to Food Camp multiple times, all the hacker events and that sort of thing. So I was embedded in the culture. And a part of what I want to tell you also draws upon that personal experience and in analyzing, from an amateur or anthropological perspective, those cultural aspects and how they contribute to the issue. Although, wouldn't it be nice though if someone with a technical grounding got together with an ethicist to tackle these issues together, right? Luckily, I had the opportunity to get together with Shannon Bowler, who's a philosophy professor at Santa Clara. And we have this opinion column, which we actually turned in just yesterday for the communications of the ACM. They invited us after seeing some of our previous writing on this topic. And it's going to be a while until it's published, but I do have a draft of this available. Feel free to email me, or I tweeted it out last night. You can look that up as well. And I should also acknowledge the help of Irina Raiku here, who's also at Santa Clara University, who gave us a lot of input. Okay, I use the word crisis. That's a bit of a strong claim, so let me back that up. So here's what I'm claiming. My point is that software has certain peculiarities compared to other branches of engineering, because of which the traditional oversight mechanisms and checks and balances that one relies on in an engineering discipline seem to break down and don't apply to software anymore. And so we're in a significantly different and worse situation because of that. So how is it different? What are these peculiarities? I want to highlight two. The first peculiarity that I want to highlight is that if you look at the typical mechanism of code deployment today, how this happens in a software company, there's very minimal or sometimes even no ethical oversight of any sort. A web company like Facebook, not Facebook specifically, but any fast-moving web company, really takes pride in this culture that a single autonomous engineer or a small group of engineers can think about a new and interesting feature, design it, code it, debug it, test it, and push it out to production all within a span of a couple of days, right? Without having to go through onerous layers of management. No, I'm not criticizing that. I'm not saying let's go back to some other model. This is great. This is, it's been a huge benefit. It's what has led to the fast-moving pace of the internet software revolution. But it has some problems that come with it. If you compare it to the life cycle of how a bridge, for example, is designed and built, right? Years long, perhaps decades long life cycle, multiple layers of management and legal and ethical oversight. All of that is bypassed here. Let me add one little layer of nuance. Sometimes you might find engineers at companies like Google complaining, oh, my product has been stuck in privacy review for like a week now. So that's a frequent complaint that one hears. However, let me point out two things. It's legal oversight, not ethical oversight. It's just oversight about whether it complies with the relevant regulations or not. And typically one even has that only for privacy, which is only a small aspect of the ethical issues that I want to consider. For all other types of ethical issues, there is nobody except the software engineers who are even in a position to think about it. And thirdly, I want to point out that even the level of delay that companies like Google incur to meet their minimum legal compliance obligations is considered very onerous by the engineers who want to move to a much faster model. And if you look at what's on the bleeding edge, you have things like continuous deployment, which is gaining a lot of attention, which is the idea that every single change you make, not even every feature you deploy, but every code change you make, you immediately test it and deploy it to production. And if you're in that kind of model, what kind of oversight are you going to have? So what's peculiar here, in addition to all this, compared to other branches of engineering, is that you have developers and engineers interfacing very directly with users, with millions of users. The layer in the middle has simply been obliterated. And because of this idea of sort of outsourcing the obligation of thinking about ethics to some other group of people within the company does not work anymore. And engineers are forced to bear this burden whether they like it or not, which is one of the reasons why for computer science in particular, I claim that ethics training in the classroom has become vitally important and something that is not happening today. So the other peculiarity of software that I wanted to highlight is the notion of scale. The whole world is zero addressable market. We know all that. That's nothing surprising. However, let's look at it a little bit numerically, quantitatively, to see if there might be some hidden surprises there. I want to point to the example, a very cute example, and I'm deliberately picking something that's not people dying or anything like that. A sort of benign but nevertheless illustrative example of a doodle. Doodles are these interesting animated things instead of logos that sometimes Google comes up with. A Les Paul doodle that Google did a couple of years ago in honor of his birthday, and a million people or millions of people woke up all around the world and found that they were able to play some kind of guitar simulation, I guess, on this thing, and they spent a lot of time doing it. Much fun was had, etc., etc. But I was curious how much time was spent on this by people all around the world. And it turns out this has been estimated, and the answer is 5.3 million hours. It seems like a large number, but is it Google large? I don't know. We don't have much of an intuition for these large numbers. So how much exactly is 5.3 million hours? I decided to ask Google. So number of hours per day, days per year. And this is average life expectancy in years, so you might see where that's going. It turns out that 5.3 million hours is about 8 lifetimes. Let's pause to consider that for a moment. Let's consider the absurdity of the difference in scale here between a project like this typically being someone's 20% project at Google, which you code over the weekend and you deploy it and you forget about it, and 8 lifetimes worth of time are spent on it. Right? I'm not claiming that this is, this doodle harmed the world. That's not my claim. My claim is that there is no process in place for anybody to think about these questions. Right? And that's a problem. And this is a doodle, but one can think about more serious examples as well. And because of this notion of scale, there is this huge and increasing disparity between the amount of time an engineer puts into something, which reflects the amount of thought also that they might have an opportunity to think about it, versus how much of an impact that has on users in monetary terms or time or whatever the metric is. So those are hopefully 2 reasons I've highlighted why, for software, the traditional oversight mechanisms have broken down and engineers need to bear this burden rather directly, which we don't have in other branches of engineering. There's other reasons we discuss in the paper that I showed you briefly, but hopefully for this purpose, I hope that I've gotten this point across. So the second thing I wanted to discuss with you is it's great to point out that there is a problem or a crisis or whatever, and something needs to be done. But from the point of view of a CS professor, if you tell someone, to me, for example, if there were a mandate from above that I have to teach ethics in the classroom, it's not obvious what I would do. In fact, I wouldn't know where to start. So I want to point to you several reasons why the structure of computer science education, as it exists today, is such that there is no obvious place to even incorporate ethics into it because of the way we teach it. I'm not saying there's a problem with the way we teach it, but it just happens to be that way. And let me show you what those are. So several reasons why ethics in the CS classroom is a harder problem than one might imagine. The first of those issues is versatility. By versatility, I mean that the computer science concepts that students who will become software engineers learn in class, right, are extremely versatile because, at an underlying level, all that computers are doing is manipulating ones and zeros. This is a graph. It's one of our beloved data structures. But what is a graph used for? It can be anything from social networks to molecular networks to anything in between. And the typical process in teaching students graph algorithms, or any other topic for that matter, is for the professor to mumble something at the beginning of the class or even at the beginning of the semester about potential applications and then delve into the details. And to teach it in a completely abstract mathematical manner, right? This makes sense? Most of you, a lot of you perhaps have been through this process, right? So I'm not saying that's a bad thing. It would be, that's where computer science education gets its power from, because we're training students to be effective in any number of industries. It would be silly to teach them to only work in the music industry or in the enterprise software industry. But the flip side of this is that the way that computer science is taught is completely divorced of context. It's not clear what you would say about graph algorithms that conveys the ethical issues to students. You might wonder, are there even such issues at the level of things like graph algorithms? Well, actually, there are. There are very subtle but very important privacy issues that arise from the fact that in a social network, for example, what can be inferred using the graph structure is much more serious than what intuitively one might be led to expect. And some of my research has actually explored this and exposed such privacy vulnerabilities. So potentially it is the case that if students did have that training in class when they're thinking about graph algorithms to learn about this issue, then they would be more careful when deploying those systems in the real world and in dealing with people's social network data. But the challenge is that we don't teach people specifically about social networking algorithms, right? The algorithms that we teach are about any kind of graph, and that's why it's not clear where to incorporate this into the curriculum. So that's one reason why things are hard. Another reason why things are hard is that most of these technologies are just very inherently morally ambiguous. This is true of a lot of technology in general. Intuitively, it seems to me that the problem is even worse for information technologies, but that's not really an argument that I want to make strongly. It's just there is a lot of moral ambiguity. That's all. So what is going on here? Here's an example. The lock icon that you see in your browser, the same digital signatures. Have some of you seen digital signatures? Do you know what I'm talking about, right? So the same digital signatures that cryptographically assure you via this lock icon that the website you're connected to is in fact your bank website or your email website. It is the same technology, in fact, that malware authors use when they're controlling a botnet full of zombies to make sure that these zombies only obey commands if they're coming from their true bot masters. Right? So completely different morally, but identical technologically, and we see this with a lot of things. You might think that, okay, with crypto, it's obvious, bad guys can use crypto, good guys can use crypto, but let me show you with another example of where you might not expect this as much, which is machine learning. So let's discuss moral ambiguity in the context of collaborative filtering algorithms in particular, machine learning more generally. Collaborative filtering, does that sort of seem familiar? Those are the algorithms on websites that recommend to you new bands that you might like or new books you might want to buy and so on. We all like them, we all enjoy them. They certainly make our web experience a lot better. Machine learning algorithms more generally for detecting credit card fraud, they pretty much run everything on the back end these days. Seems like a great thing. What might go wrong here? Let's look at a few examples. Some of you may have heard of the filter bubble. The filter bubble is the idea that when websites, Facebook, Google, whatever, use collaborative filtering and learning techniques in order to show you what information you might most like by analyzing your past behavior, the idea is that this will lead to a reinforcing feedback loop, and then you will be isolated into your own bubble of reinforcing viewpoints. That's the filter bubble. In general, the notion of treating similar users similarly, which underlies a lot of machine learning, if you abstract the context away and apply it to a different context, demographic groups, we see the phenomenon that nudging people into behaviors based on how similar users behave directly has the power to deepen existing social and demographic disparities. Recent research, pieces of research showed that there is, because of such machine learning systems, there is racial discrimination in online ad delivery. I don't mean discrimination in the social sense, but at least in this context here, more in the technical sense of different groups of users being treated differently by the same system. There's also research into how prices and deals on websites vary based on your past information. So these are all examples of how machine learning introduces subtle but systematic biases and unfairness into various systems. But there is something, when one talks about the ethics of machine learning, that's of even more concern to me, and this is the notion of digital due process. What do I mean here? When systems that have power over us, like the no-fly list or health insurance and a variety of other things, now make decisions based on machine learning, based on reams of data that they have collected about you through a completely opaque process. Okay? Which is where machine learning, in fact, draws its power from. It's because a human didn't sit down and write those rules. It's because the machines learned them by itself, and it's not even representing those rules in a manner that a human can understand. It's representing them in a manner that you transform this giant matrix of ones and zeros into that other giant matrix. Right? So when such systems are used to make decisions about us, like not letting us get on airplanes, then we have a problem. It means that the notions of due process have broken down. And this, the notion of technological due process was first raised in a powerful paper by Danielle Citron, and that's where I'm drawing this argument from. So this was hopefully an example of how machine learning, something that we do not think of as having these two sides, as in fact right in the middle of this ongoing debate about ethics and fairness and due process issues. So that's the second reason why teaching ethics in the computer science curriculum is hard, because everything that we teach has this very interesting duality. We can't just say, oh, these are good technologies, let's teach these in the classroom, but not those other technologies. There is a third reason. And to explain that third reason, let me ask you this. The example of racial discrimination that I mentioned a second ago in online ads, do you think there was a programmer who coded that rule into the system? Actually, there wasn't, right? Even though a non-computer scientist might intuitively assume that the only reason the system displayed that behavior is that somebody programmed it in. If we think about collaborative filtering, that's mostly not the case, not the reason why that system emerged. It's an example of how machine learning and collaborative filtering can reflect as well as deepen existing disparities. The most likely explanation for that behavior is that it was an emergent property, a side effect of a system that was designed for other goals, such as maximizing click-through rate. So more generally, notions of fairness in machine learning and a bunch of other ethical questions are open computer science research questions. This is a fantastic paper by these 5 people that comes up with a whole new mathematical theory of what fairness means, and they're rejecting older ways of thinking about fairness as saying the system should not do these things, but they're coming up with a new way of saying, let's define what is an acceptable behavior for a system, and then let's define fairness based on that model of behavior. I'm probably not doing justice to it, and the reason for that is it's a definition that's mathematically as intricate and advanced as differential privacy, and it's in fact by a lot of the same differential privacy people, and some of you may have seen differential privacy and how mathematically complex that is. So that's where the state of the art in research is. It's not even as if everybody has agreed that this is the right definition. So we're still arguing about definitions and coming up with complicated mathematical formulas for what it means for a system to behave in a fair way. And we're a long way from having some sort of general procedure given a task to design a system in a way that meets those specifications as well as having these fairness properties. Right? And so because of this, to a computer scientist teaching these algorithms in the classroom, it might seem like a hopeless task to even define what is a responsible way to deploy these algorithms in the real world and to teach ways of doing that. So those are the reasons why this is hard, but I'm going to come back to, nevertheless, what are things we can do and why this is not a reason to give up. But now, one thing that has been really of interest to me in the last few years that I want to share with you is looking at hacker culture and thinking about how hacker culture might contribute perhaps to some of these ethical issues. So presumably most of you are aware of the sense in which I'm using the term hacker, but let me highlight two properties that I think we can all agree on that hackers are supposed to share. You can just go to the jargon file and look for what comes out of it, and I would say that it would be very close to these two attributes of hackers. One is that they're motivated primarily by curiosity and fun, rather than more crass motivations like like making money or whatever. And the other is they look for creative ways around barriers. Right? This sort of makes sense. We've all seen a lauded, very fond descriptions of hacker culture that applaud these two properties and take a lot of pride in them. So let's start from these two properties, and let me explain to you what I think I've seen again and again, and a lot of you may have seen as well, how this leads to a typical workflow of software development. So you start from having a set of requirements for what it is you want to build, and you turn that into a specification. That makes sense, right? But the thing is, once you've turned it into a spec, you've defined it as a purely mathematical or technical question, and you've reduced it, you've mapped it to what you learn in the computer science classroom. It's a graph problem or something like that. It's not a people problem anymore. At this point, you've reduced it to a problem of manipulating graphs in a certain way. So there is a short step of coming up with the specifications, and at this point, this is probably everybody's favorite step. You retreat into a happy hacker state of code sorcery. Right? Find creative ways around whatever limitations there are of the system that you're working with and whatever barriers there are to achieving the goal that you want, and you come up with a solution. Now, this is great. I'm not criticizing this. I miss my happy hacker days, and it was one of the things I had to give up when I became a professor, and I miss, going several days at a stretch just thinking about how to twiddle bits and turn this set of bits into that set of bits, right? It's beautiful. It's great. But the problem is nowhere in this process are you thinking about what is this thing you're building? How is it making the world a better place? Who's going to control it? Is it going to be used? How can it be misused? Did you have a thought?
It seems like you've sort of left two steps off of the workflow.
Okay, go ahead.
One of which is coming up with the requirements in the first place. And the second is evaluating the requirements after you've finished the solution.
Right, and I think that's going to be in my third step, which is typically hackers think about all of these, club all these non-technical issues into something that you take your finished product, and then legal teams or compliance teams are supposed to work out all of these other issues, and maybe you stick something into your terms of service document to explain what you did and didn't do. Did you have?
Yeah, I mean, I guess for me on the projects that I worked on, even here, first thing we do is like, this looks like a tricky problem. We're going to go to legal, we're going to the general counsel now, because we don't want to waste any time writing code, writing specs, doing anything that we know is potentially fraught with problems.
Okay.
So maybe I'm ahead of the curve, but it seems to me that part of the requirements and part of that initial step is working out this compliance issue and working out these technical things.
Fair enough. The thing, though, that I'm taking issue with to a certain degree is this factoring between the technical problem and all of the other things into two orthogonal entities.
Yeah, I mean, let me ask that a related question, I guess, which is this a problem with software developer education, or is this a problem with the way the technology companies are managed?
I would say that it is both. Here I'm trying to isolate and focus a little bit on the education aspects of that puzzle, because like I was saying a little bit earlier, even at the level of machine learning algorithms or crypto or whatever, there's a lot that one can learn in the classroom about what are responsible ways for. Yeah.
But if you think about this, your data center encryption example, presumably it was a management decision within the company to devote resources to something else rather than that, as opposed to the software engineers who could have implemented that solution not recognizing its value. In fact, the evidence that we've seen is that the software engineers are really upset that the decision not to implement that feature turned out to be a mistake.
Well, sure, that's great. And for certain scenarios as opposed to others. More of the responsibility might lie with software engineers as opposed to management. But let me point to another example where I think it probably would lie more with the engineers than with management, and that was the online ads being racially different. In that example, software engineers are the ones who are more likely to be in a position to realize that the algorithms they were implementing have this property which no one else might easily be able to realize and to be able to do something about it. I'm not putting all of the responsibility or blame or whatever on software engineers, but they certainly should and must shoulder a lot of the burden, which probably is not happening today.
So there's two different kinds of ethics that are in danger of being conflated here. Right? Professional ethics in law and medicine are really not about social impact. They're about principal-agent problems and conflicts of interest. And one of the sort of cornerstones of legal ethics is you do not ask the question of, is it socially beneficial for the client to win? Right? Once you have agreed to represent a client, you work for them and not for society.
Okay.
And there's a whole set of engineering ethics principles along these lines about if you agree to build something, you should build it properly, and you should not do shoddy work and so forth. And there's a separate question about social impact. And my impression of this is that the traditional engineering ethics view is we do not want engineers to do that. Mm-hmm. And if an engineer agrees to build a bridge, we do not want them to ask about the ethical consequences of building it here versus there. That decision has been made a layer above, and the engineer should do their job.
I think we're in complete agreement.
This is sort of lumping those together.
Yes, and it's and I started out that way by saying that this factoring that we've seen in the past, like bridges was exactly the example that I used, where engineers do the engineering, and then there are multiple layers of management and ethics and legal in order to think about all those other issues. That's breaking down because engineers are deploying code directly to end users, and so that process is not working so well anymore. And so I do want to lump those things together, and that is in fact my intention here. And that engineers should bear the burden of thinking about the social value of what they're building.
So the argument is that management is not really in control of what's getting deployed?
In many cases, or does not have the full information to realize what the impact is going to be. Josh, did you have your hand up as well?
I did. I was going to ask about exactly this question. So most of the engineers that I know really do think about the ethical implications or the social implications of the stuff that they're building, but the problem is not that they feel that the problem is exactly as Ari mentioned, that they feel that they can't escape this abstraction that you're describing. So I think that gets back to Ed's point that it's really more a question of management. So if I'm an engineer, if I'm employed as an engineer at a company, and I feel that I'm being asked to build a product that I think is unethical, then my job is to build it anyway and do a good job, and that's what I'm measured on. But I may recognize that, and in fact I've seen a lot of situations where people do recognize that, and they feel that they can't influence the upper layers. So maybe that's maybe from an education perspective that kind of enablement is the right answer. It's not to say that that they're not recognizing the problems, but to say that they don't know how to apply their skills or communicate that what they're building has dangers associated with it, which layers above them, like layers of decision making above them, legal and compliance and management, may not necessarily be aware of, and those kinds of issues may be more amenable to direct educational. I guess they may be ameliorated by education in a more
That's a
direct way.
great point, Josh. Thank you. And I guess something that comes out of that is perhaps an argument for more of an activist role for engineers within companies.
Yeah, so I was just going to elaborate on that. There's sort of two things. One is that most of the managers, in a tech company who are sort of the first line managers or even the second line managers or even all the way up to the top were once the coders, software engineers themselves. So by jump-starting this process, eventually that will help. But I think you're right in terms of having a company with a corporate structure such that, it's okay for, the coder, the low-level guy to, raise, a concern up the food chain.
Mm-hmm.
If you have a corporate culture where that's encouraged and listened to, that would help a lot. And that in and of itself is sort of an ethical issue that you would want to set up the culture and management of your company in such a way that it encourages this kind of behavior.
Very good point. Thank you.
I'm not sure this is true, that people are making ethically fraught decisions without management input. Right? My experience of this is that even at very small tech companies, there's a lot of code review. And
code review is not ethical, right?
But I mean, people are paying attention to what you're doing. You're not off there on your own. You do have peers who are watching you. And if there's any sort of non-trivial issue, people will go to management and say, wait, engineer A says, they want to deploy this awesome feature, and engineer B says, this will get us in trouble because the feature will have sort of ugly social consequences. I mean, people do notice these things. I just don't know that that's really the case. That
I will disagree with
off on their own.
I will disagree with one point there. It's almost never about ugly social consequences. It's about ugly compliance or PR consequences, and that's one of the things I'm taking issue with. Josh.
Arvind, isn't that an argument that says that we should take some of these issues and that we should have compliance regimes that cover them? I fail to see, there are legitimate problems out there like privacy, which have, compliance regimes, at least in some jurisdictions. And then there are other problems, and I fail to see sort of bad other problems that fit outside of things that we already have policy debates about.
I would disagree with that, and the whole machine learning discussion was supposed to be an example of something that, there's no awareness in regulatory
circles. There are policy
circles.
discussions around discrimination. And
Yes,
there are
and-
compliance obligations about discrimination.
And around disparate impact in particular.
Yes, but from my discussions with legal scholars, none of the specific examples that I talked about get near the level of legal proof that you can get in order to talk about disparate impact, even though from a moral point of view, they seem to have that effect in practice.
This is more of a question, and it gets to what you said about medical ethics and conflict of interest and that sort of thing. It seems to me that also the culture, and maybe this is sort of the Silicon Valley culture, where okay, we're gonna pay you peanuts, but you're gonna get stock options. So now there might be a motivation that maybe it's not quite aligned with social benefits.
Okay, that's interesting.
So it's just sort of a comment rather than a question.
Yeah.
So this notion of I as someone building something under the direction of someone else, and I think the thing that I've been tasked with is unethical in some way. This doesn't seem exclusive to technology or computer science. I mean, you imagine in financial engineering or really almost any industry seems like they would have similar problems. I mean, are there sort of parallels here that so I guess what is it that makes computer science unique? Is it really just that there's so little oversight, or
right? Two things. One is I'm claiming that it's to a much lesser degree than in other cases where that in software engineering you're tasked with something that's been through layers of oversight and so on. You're tasked with something general, and then you're pretty much as an engineer in the position of designing and deploying that feature, not just as an abridged calculating load or other technical things, but in terms of do you keep the data on the client or on the server, right? You're the one in charge of that decision. So there's a lot more responsibility. And what was the other thing I was going to say? The other thing I was going to say is that in a lot of cases, the engineers are the only ones who are even with the information and an understanding in order to be able to make these decisions in the first place. So even if you do have processes in place at the other layers, it's not going to help. Josh?
Aren't there typically product managers or project managers who fill that role as well? Like on a bridge project, presumably there's a project manager, part of whose job is to make sure the load calculations get done, part of whose job is to make sure that site selection gets done in a way that's, trades off correctly between the function of the bridge and something like environmental impact.
Yeah, so for the last few minutes we've been arguing hypothetically about how something does happen or does not happen in companies. So I think what would be useful here at this point is for me to show you an example that I was going to show you of something that happened just a week or two ago, of something that I feel went pretty badly wrong, and talk about why that might be the case. And that kind of fits into, I think, this hacker mentality workflow. So LinkedIn introduced a feature. Did you guess that?
I just said, I bet it's LinkedIn.
Yeah. So I'm guessing that many of you have seen this. So LinkedIn introduced a feature called Intro, the point of which was to integrate into Apple Mail and to turn an email that looks like this into an email that has this one extra line that shows you some information about the sender of the email that was fetched from LinkedIn's databases. Right? And Apple Mail is not the most extensible system, and so the LinkedIn people had to do a lot of hacks to get around these barriers that Apple Mail inherently puts into place in order to accomplish this feature. And some of those were using CSS instead of JavaScript in order to do dynamic tasks, which you might intuitively not think possible based on a knowledge of web programming, but they found ways to do that, which was already pretty interesting. But the major feature that raised a lot of concerns with people was this very interesting way of getting around a fundamental barrier that they encountered with Apple Mail, which they figured out for themselves, but already has a name in the security community. It's called the man-in-the-middle attack. So they basically found a creative way to route all of the users' email through LinkedIn servers in order to enable this little feature. And I was also very surprised to read the technical post describing how they did this, and it was titled "Doing the Impossible on iOS." I don't want to pick on this person. This is something I've seen time and time again. The only difference this time was that all of this happened in public, so it's a great example for me to take screenshots of and show to you. So it's called Doing the Impossible on iOS, and if you read this, it just fits perfectly with the hacker mentality. This person is just so excited about getting around all of these technical limitations. Nowhere in the post, and I don't know whether privately, did he pause to think why these limitations are there in the first place and whether they might serve a function that's beneficial to the user. And that was pretty jarring to me. And the kicker, from my point of view, was a line at the bottom saying security and privacy. Personally, I think it would have been better if he had left that out of the picture altogether, if he had said nothing at all. But this shows that they have given some thought to security and privacy, and their answer was essentially, LinkedIn takes your privacy seriously, go read our privacy policy. Okay? After doing a man-in-the-middle attack. So a lot of people...
When was this? When did this post go up? Did it go up before or after the furor about this?
Before the furor. Actually, the screenshot, if you look at the page now, it says updated, and there's a little bit of an update with more disclaimers, and so that's what I wanted to talk about. So the response to all the outrage was another post by LinkedIn, which explains in great detail how they handle your email carefully after stealing it, completely missing the point of the objection that people had, which is why are you grabbing all the users' emails in the first place when that's not what they're asking you to do. Right? So I think what we're seeing here is a cultural view of reducing the problem to a technical specification, and then finding creative ways of solving the problem. And then this mentality that whatever the privacy or ethics concern with the feature, you can pretty much solve it by doing these other extra steps at the end of it, or putting something in your terms of service. And I noticed, the first time I noticed this was in several conversations with various companies where they would ask for my privacy input on something. I did not succeed in trying to convey to them that some features probably should not be built because of the privacy and ethical reasons. That was not registering. What they wanted to hear from me was, we're going to build this feature. What is that 2 extra steps we need to do at the end in order to make the concerns go away? And what I'm claiming should happen does not fit into the model of how companies seem to want to think about it. And that's where I feel there's a little bit of a fundamental cultural problem. We can argue exactly the nature and the layers of management and so on, but I think there is some fundamental mismatch here that I hopefully have gotten to with this example. So just a few concluding thoughts of how computer science educators can move things forward by making a difference in the classroom. One of the things I want to say is I wanted to say that there's going to be a lot of use in doing a dehabituation and rehabituation of computer science students and software engineers. Going from this kind of habit to this kind of habit, where every time you're writing a piece of code, you're habituated not to think about it in terms of bit manipulation, but in terms of what it's going to be actually used for, and be asking all of those questions even when you're writing that code. And specifically, one way we can do this is that even though each technology has many, many possible uses, hand select a few chosen applications and case studies. And I feel that it would be very useful for us to collectively come up with a repository of such case studies broken down by type of ethical issue and type of sector or whatever that they arise in. And I made a tiny bit of an effort to get the ball started on that with a post here a few months ago, asking for real-world examples of ethical dilemmas that software engineers face. And a lot of people responded on the post and by email and by Twitter and so on. I collected those into another post that led to an ongoing conversation. And so I feel that by developing that into a body of knowledge of case studies and analyses, we can have an impact. Another suggestion that I want to make for educators is to instill a notion of professionalism into software engineering, which a lot of hackers in particular really resist a lot because it has seems to have all of these other onerous implications of barriers to entry into the profession and being ossified into certain practices that get quickly outdated and so on. But it's not necessary to incorporate all of those aspects that are considered unwanted, but only take at least what we can all agree is very useful, that from the ethical perspective you get out of professionalism, is a Hippocratic oath, by the way, which is a sense of duty and this notion of a community of others who are all faced with these same dilemmas and with whom you can interact in order to find solutions to these questions, and various standards and codes for, because a lot of these dilemmas that come up, they do come up in the same form again and again in different contexts, and standardized ways of at least mitigating these issues, if not completely solving them. So, yeah.
So I was just going to say, I'm pretty sure that the IEEE and the ACM and the League of Professional System Administrators and a lot of things.
The organizations exist.
Yeah,
the organizations exist.
And they already have.
What is missing is a sense of professionalism.
Yeah.
So up until I started doing this, I certainly didn't feel like I was part of such a professional group of people. Even back in my hacker days, and when my co-author on this, the philosophy professor, suggested that professionalism is important, I in fact resisted initially. I said, we do have organizations like the IEEE and ICM, but I told her I haven't taken them seriously. And she changed my mind. And I feel that that's important, and we can propagate that forward.
There's an interesting model you can look at for doing exactly this in the privacy world. There's a group called the International Association of Privacy Professionals. It kind of came out of nowhere 5 or 6 years ago. And they've developed an entire cottage industry certifying people for their understanding and knowledge of privacy, and their ability to recognize not just the legal compliance problems, but the ethical issues.
That's a great point. Thank you. Yes, the IAPP is a very good model. If there is one thing that I would tweak for the software engineering case, is less of a focus on compliance and more in terms of externalities and social benefit.
But for the professions, you need to have a consensus on what the professional ethical rules are.
Okay, fair enough.
In the legal profession, we have something called the Model Rules of Professional Responsibility, and they were argued up and down until there was finally an agreement by the American Bar Association on what those standards should be.
Interesting.
But once you had sort of your 10 commandments, then all of these other things can fall into place much more easily.
Thank you.
I'm sorry, just to interject.
Yeah.
ACM and I think other groups have codes of ethics.
So the social sciences, most of the impetus of this has come from NIH and NSF. The funding agencies require certification of any researcher in ways that have gotten a little bit more demanding. So there's now a course that you have to take online and actually answer questions for. It takes about 4 to 6 hours. Princeton's interpretation of the rules is that each department has to offer a curriculum. In our case, sociology, we do a 6-week course in research ethics. Have the federal funding agencies gotten involved at all in computer science and ethical issues?
I don't know the answer, Ed. Do you know?
There is some sort of mandatory research ethics training which is required if you're federally funded. And all of our graduate students in computer science have to do that.
It was content free.
I'm not endorsing necessarily the particular program we have here, but it is mandatory.
How long has it been in place?
It's a few years back. There was
I don't remember it.
There was a new it was after your time, but it's due to a mandate from Congress ultimately.
Let me end what I wanted to say with one little advertisement, and then we can go back to discussing for as long as people are interested. So Professor Shannon Baller, who is my co-author on this opinion column, has written this module, which is a self-contained module, and as an introduction to software engineering ethics. Since you mentioned that that was content-free, this one is certainly not. I really like how this turned out. This can be administered by an instructor, like in one of your classes during the semester. And ideally, what I would tweak about this is a way for each instructor to customize it to the topic that they're teaching. But her specific goal was to make it completely self-contained. So that's great. Regardless of which model you go with, I think doing this is much better than not doing anything at all in the classroom. So I would encourage you to take a look at this. And my final thought is that we may not have all the answers, but I think it's important to train students to ask the right questions. Thank you.
So my understanding of the way that professionalism happens in other fields is that if you are a lawyer, the government is giving you certain legal rights and privileges which other people don't have, like the right to represent clients in court, which I can't do, and the right to not have to testify, which I can't do. And the deal is that the lawyers promise to obey these very specific things. The government gives them certain authorities, and in addition, there's this other bargain between the lawyers and the clients, which is that the lawyers promise that they will punish any lawyer who behaves badly and rips off the client, and in return, we, the clients, feel more comfortable hiring them. This isn't a good parallel for computer science because there isn't any sort of particular legal rights that you have as a software engineer. Right. That there's no category of only the professional sysadmins will be allowed to administer systems.
Certainly.
We're not going there.
Well, there is actually talk about that. There's talk about having professional engineering for software designers and builders.
This is very far away, and this would make everybody crazy because a huge fraction of the country writes code. So there's this notion that there's like a small number of people who are software engineers, and then the rest aren't. This is false.
I'm going to interrupt you for a second.
10 million people write code.
Yeah, I'm going to interrupt you for a second. I think we're taking a word that I used and using it in a way that I did not intend at all and arguing about that. That's a different conversation we can have later, but all that I'm saying is a sense of professionalism, which is very different from legal obligations and rights for a certification.
These are not
exactly.
The way that this is maintained is that you have a barrier on the way in. If anyone is allowed to write code, you're not going to be able to go to them and say you must have these values. People just wander in and they'll do it their way, and they'll be ruthless because we had no opportunity to reach them.
You clearly have strong opinions about it. I'm not going to change your mind here, so let's take it offline. Josh.
I guess your proposal is that we should integrate ethics education into the CS curriculum in some way, and in fact that's the module you just showed on the last slide. I was curious whether you think it would be sufficient to sort of train people in computer science and separately to train them in ethics.
Right, as in like a whole separate course.
Because at a liberal arts institution like Princeton, people certainly have the obligation, like CS majors certainly have the obligation to take courses also in the humanities.
Right, the more the better. I'm not at all arguing against that. But my point is that there is a certain component of the CS ethical education that can probably only come from computer scientists because it involves tricky technical issues. Karen?
So I recognize that you're not trying to propose an ethical solution to every possible problem that computer science implies, but there are two types of problems that I think are relatively different from things like the LinkedIn case study that you presented, right? And one of them is stuff like the filter bubble, right? Like one individual recommendation engine doesn't maybe have like a really obvious ethical valence, right? Or it's aiming to solve a problem, right? Like tell me what New York Times articles I want to read or what movies I'm going to see. And that seems like a positive social good, right? It's when all of those systems get aggregated, right, that then we have problems with, like maybe I'm only looking at and reading things that are exactly like other people, or other people like me are doing, right? And so I find that type of problem a little bit intractable, just because the harms are sort of a result of the aggregation and networking of a lot of systems like these, not any individual system. And then the second problem, which is something you and I have discussed before, is about what types of problems get worked on in the first place. So I know that, like you mentioned to me, I think at one point, like we have dozens of apps that, tell you how to get someone to do your laundry or how to hail a cab, right? Like all of these 20-something single male Bay Area problems. And we don't have like easy computer science solutions for like solving, we don't have like a great system for social welfare for people who really need it. Which also is an ethical issue inherent in computer science work. And so I'm just curious how you think your framework will address problems like that.
Right. Well, I don't have a framework, by the way. It's not
Yeah,
nothing as ambitious as that. Just
have too much.
a few humble suggestions for what computer scientists could start doing. Well, one thing I will mention, which is, does not directly address your questions in any way, but that Solon Barokas will be joining us as a CITP fellow soon at some point, and he's doing his PhD thesis on a variety of ethical issues in data mining, and in fact has a chapter on all the discrimination issues that I mentioned briefly in a slide. So he would be another good person to talk to for anybody who's interested about questions like these. Not that he's going to have all the answers ready, but definitely a thinker on these issues. Do not know how to think about issues that arise not because of the actions of one individual or company, but because of the aggregation of all of those. In terms of what problems get worked on, I think there is an ongoing conversation about that, and it is in that context that I mentioned the Hammerbacher quote about all the best minds of our generation working on ads. And I think what has happened in the last few years is there has been a rise of the social hacking movement. I see a variety of different organizations and efforts that are part of this. My friend Mike Brennan in Philly is doing, I forget what he calls it, Hacks for Good or something like that?
Random Hacks of Kindness.
Thank you. Random Hacks of Kindness. There's the Hacks and Hackers initiative for coding together with journalism for the public good, and perhaps a variety of these efforts that are outside of the commercial system that's focused on the bottom line as part of the answer to that challenge.
So interesting. This weekend is Hack Princeton.
Thank you.
Seems to me you could put up some signs around this building and CS and share it that just simply says hack ethically.
Yeah.
And just get it there.
Yeah, that makes sense. I think that's a good note to end on, perhaps.
Sure.
Yeah.
And let's adjourn to informal conversation. Just a brief promotional message.